All right, this is part 2 of Investigation 4B, and we're about to start talking about Table 1. So I'm going to read this little paragraph, and then we're going to spend some time sort of labeling Table 1 so that you understand what the columns in Table 1 are. Table 1 is a list of the major sediment transporting rivers of the world, along with their mean annual discharge in cubic meters per second, their drainage area in thousands of square kilometers, their mean annual sediment transport in millions of tons per year, and sediment load, which is in kilograms per cubic meter. Okay, so what I want to do is you're going to go back to the back where you have Table 1, okay? And here are the 4 columns that we just talked about: discharge, drainage, sediment transport, and sediment load. And here are the rivers that they have in the table. What I want you to do is take a few minutes and label the columns the way I'm going to have them labeled so that you understand what each column means. Okay, so you all know me, I'm a color coding kind of person. So this first column, so I turned the table sideways so I could color it. Discharge tells you the volume of water moved in a certain amount of time, like how much water flows past a certain point in a given second, okay? So this tells you how much water is moved, okay? This second column, drainage, really is drainage area. It's the area or the amount of land that drains into that river. So if you think back to the Mississippi River drainage basin that we looked at, it was a large area of the United States, okay? So the drainage area tells you how much land is draining into that river. The third one, sediment transport. This is the number of tons of sediment carried by the river in a year. And then this last one, sediment load, I kind of call it your muddy index. Because it's how much sediment is in a certain amount of water. So for instance, if you had a cubic meter of water, like a box that was a meter by a meter by a meter, and you filled it with water, and there was a lot of sediment in that water, then that water would probably appear kind of murky and muddy. Whereas if you filled up a cubic meter of water, if you put a cubic meter of water and there's barely any sediment in it, then the water is going to be pretty clear. So hopefully that gives you an idea of what I mean. Okay, so that's kind of a muddiness index. The more sediment that is carried per cubic meter, the muddier the water is, basically. Okay, so take a few minutes, get all of this labeled so that when we start answering the questions, you have an easier time referencing the table. Okay. Below the table, just to make sure you're listening, why don't you put a smiley face? All right. I'm right up here. With the help of a world map, if necessary, locate the following rivers. Okay. The Amazon of South America is your main tropical river. All right. I'm going to pull this image up. Here's the Amazon. Okay. The Irrawaddy, Brahmaputra, and Ganges, also the Kosai tributary, Mekong, and Indus are southern Asian rivers where monsoon climates prevail. Remember, monsoon climates basically have a rainy season and a dry season. Okay? All right. There's the Ganges, here's the Indus, the Brahmaputra, here's the Mekong. One or two of them that they mentioned were not labeled on this particular diagram, and that's not a big deal. Anyway, but they're all rivers in this sort of Southeast Asia area. The Nile drains from tropical African highlands across arid land north to the Mediterranean Sea. All right, so the Nile River is right here, traveling north, draining into the Mediterranean. The Mississippi, Missouri Red River system and the Colorado drain mid-latitude North America. Y'all should be somewhat familiar with those. Here's the Mississippi, Missouri River system. Here's the Colorado River system. And then the Changjiang, or otherwise known as the Yangtze River, and the Huanghe, otherwise known as the Yellow River, systems of China are also located in middle-latitude temperate climates. Okay, let me show you where those are. Here's the Yangtze, and here is the yellow. Remember, that's the Huanghe, and this is the Changjiang or whatever. Okay. From Table 1, the river with the greatest annual sediment transport is, what is it? The Amazon, the Ganges, or the Huanghe River? All right, go to your table, and sediment transport is this third column. So if you look down the column, find the largest number in that third green column, and it's 1,890.9. And that is the Huanghe River. So the Huanghe is actually transporting the most sediment per year. Okay? Number 7, the Amazon River annually discharges, what is it, 1, 10, or 100 times the annual discharge of the Mississippi. Okay, so go back to Table 1. This time we're going to look in column 1 because that is discharge. We're comparing the Amazon, which is 181,200, to the Mississippi, which is 17,800. Okay? How many times more is the Amazon than the Mississippi? Well, what you're going to do is you're going to take 181,200 and divide it by what the Mississippi is, which is 17,800. Okay? Okay, and when you do that math, you come up with just over 10. So that means, for number 7, that the Amazon River is moving or discharging 10 times the water that the Mississippi River discharges. Basically, the Amazon is moving 10 times the volume of water as the Mississippi. Okay, number 8, the Amazon River's sediment load is how many times the sediment load of the Mississippi? Well, again, we've got to go back to the table, and we want to look at the column that says sediment load, which is the last column. Okay, this is kind of our muddiness index, remember? The Amazon sediment load is 0.1. The Mississippi, 0.6. Okay, and I want to know how many times. So what I'm going to do is I'm going to set up a fraction again, 0.1 divided by 0.6 to get my answer. Okay, so make sure that you're writing down the actual math. 0.1 divided by 0.6 gives me 0.1666 repeating, which rounds off to 0.17, which tells you that the Amazon is less muddy, basically, than the Mississippi River. Okay, it's not carrying as much sediment per cubic meter as the Mississippi River is. Okay, now, number 9, taking into account that the Amazon River receives heavy tropical precipitation over a large drainage basin, the total sediment transport and sediment load are relatively small compared to other rivers listed in Table 1. Now think about the area that the Amazon River drains. The Amazon River, remember, is located here, and it's going primarily through tropical rainforest jungle area with lots and lots and lots of vegetation. Okay? So, even though the Amazon is moving a lot of water, it's moving less sediment relatively than the Mississippi. And the reason for that is that the Amazon is covered in vegetation. And vegetation holds on to soil better. The roots of all of those plants help hold the soil in place. If you think about the area that the Mississippi River is draining, a lot of that area that's drained by the Mississippi, a lot of this area is farm area, okay? And y'all know that sometimes crops are planted in that farmland and sometimes it's just bare soil, okay? So you're going to have more sediment transported in the Mississippi River drainage basin than you would in the Amazon, because the Amazon has extensive vegetative cover, which is the reason why you have very little soil winding up in the Amazon River. Okay, just for fun, draw me your best piranha, which is, one of those fish that everybody says, eats people, which are supposedly in the Amazon River. But anyway, so draw me your best piranha out to the side of number 9. And then join me for the last, hopefully the last screencast, as we'll finish this assignment up. All right, I'm now on page 3 of your assignment where it says Mississippi River sediment transport to the Gulf of Mexico. Actually, what I'm going to do is I'm going to end this screencast here so that I don't run out of space. So join me for screencast number 3, and that should take care of page 3 and take us to the end of the assignment.